All right, let's start. Okay, so today's topic is database normalization. And if you look at the title in your book, it says normalization to third normal form. I will go over a brief description of what normalization is. But later on, before we get into any detail or any specifics, I would like to give you a bit of a background that leads up to database normalization. All right. So let's have a look at what's written here. It says normalization is the process of structuring data within a database. The process starts with a flat file and finishes with a set of related tables. It is a formal method of ensuring that each table is structured correctly and does not contain redundant data. Redundant means data which is repeated or which is repetitive, which is extra. Okay. So if we go by the definition, it says that it is a process, or normalization is a process of organizing data in a structured form where, to begin with, you start from a single flat file, a single table, I would say. And as you take that single table or single flat file through the stages of database normalization, at the end you would have converted into a set of related tables, which means that a set of tables that are joined in relationships. All right. Okay, now before we get into any specifics of this, where does it all start? When any organization wishes to collect data about whatever purpose that they would like to use the data for, it all starts from, a very basic activity of first figuring out what is it that you would like to collect and store. What is it that you would like to collect and store? For example, any business, any business that would like to, start its operation and would like to, store data that they would be needing to carry out that business on a day-to-day basis, will have to first think in terms of what is it that they need to collect. They would have the business objective in mind. Okay, what is the objective of our business? So when they have the business objective in mind, keeping that in mind, they would know what type of data would they need to work with. So it all starts at a very basic level where you start thinking about what is it that we need to collect and store. That is where, the process of creating fields starts. Okay, so you first, remember we were talking about in our discussion on databases, we were talking about, what are entities, what are entity types, what are attributes of fields, and so on. So it all starts at first identifying entities, specifying entity types, and then thinking in terms of what data would we like to collect about a particular entity or entity type. That is where the attributes are going to come in, or the fields are going to come in. So to begin with, you are not doing anything on the computer, you are just writing all this information on a piece of paper. Yeah, all the fields that come to your mind, you do not have to worry about which entity would they belong to and so on and so forth. You would just first write down everything that comes to your mind about what data would you like to collect and store. Now, once you have sort of written it on the paper, you have an entire list. Even if it is not organized at that point in time, it is okay. The next step would be to start thinking in terms of how those fields could be grouped. Which fields logically relate with each other. So you start putting them all together. Okay, well, there's a certain set of fields that logically relate, and they should be probably in one table. You put them all together, and then maybe another set of fields, and then another set of fields. So when you start doing that, you start getting a picture of as to probably how many tables at the end of the day, you would be needing to store that data in. All right. So once you have categorized all the fields on a very basic level. You have sort of uh, categorized them into probably various sections that would eventually make your tables. All right. Now, once this is done, all this information that you have written for the time being is all together, that hasn't been distributed as yet. All right. So this is where it all starts. You know, later on, you will, even when it comes to normalizing the database, still at this point in time, you would not have done anything on the computer as yet. It is all on paper at the moment. All right. So once you go through the process of converting that single flat file or table into a set of related tables by specifying the fields that would belong to a particular table, you would start thinking in terms of the relationships. But even, of course, even before that, you will have to be specific in terms of what primary keys would be there in tables, what will be the foreign keys, what kind of relationships would there be between the various tables. So all this is first going to be done on paper. Once your database, or you have taken your database through the process of normalization, okay, from the start till the end, as it says, in this description as well, when you take your data through the stages of normalization, at the end you would achieve a set of related tables. Now when you get to that point, it is then that you will actually sit on the computer, use a DBMS, or a database management system, and start implementing it practically on the computer, as I said, using some database management system or a program. All right. So this is what it is. Now let's have a look at how do you basically, to begin with, how you start structuring your data. So some conventions that are used in normalization are, it says that when describing tables, the following conventions are used. So if you look at it, on top, you have your table name, which is usually written in all caps or in block letters. Maybe you can say that it is all written in caps. Next comes in the primary key in that particular table, because we do know that every database table must have a primary key. Now, when you specify your primary key, you must underline it to separate it from the rest of the fields. You must underline it. Next come in your attributes. So the table name in block letters, the primary key, and then of course the attributes or the fields. You know that attributes may also be called fields. Okay, either you write it this way, where you give the table name at the top and then you write the primary key, you underline it, and then the attributes, or else you may also give it this shape, because remember, right now you're just writing it on a piece of paper. So either way, else it could be the table name written like this in block letters, and in brackets, in round brackets, you specify your primary key, which is again underlined, and you separate every single field or attribute in that table by a comma. So the primary key, comma, attribute 1, comma, attribute 2, and so on. Depends upon how many attributes or fields there are in that particular table. So as it says, you could see here that it says the table names will be in capitals, primary keys will be underlined, attributes will be listed below the table or within brackets. That's the convention that you usually follow when you're writing it down. Okay, now let's get down to what are normal forms. Now it all starts with, as I said, of course, after having done the basic homework, you move to the point where you have your database in unnormalized form. Any database which hasn't been normalized yet is unnormalized, and it is called UNF, the unnormalized form of the database. So the unnormalized form of a database is basically a flat file. because after normalization, will you actually convert it into a set of related tables. So right now, when it is in unnormalized form, or by the way, it is also called, the unnormalized form is also called sometimes 0NF. This is not O, this is 0NF or unnormalized form. Okay, now in order for the database to be converted into the first normal form, what do you have to do? It says the database in unnormalized form will contain non-atomic data, repeating groups of data, and possibly redundant data. Now, what is non-atomic data? Non-atomic means if you have more than one data items stored for a single field. For one field or one attribute, you have more than one data items. Let's have a look at this. This table contains non-atomic data. If we have a look at this table, there's a product ID, description, and price. Now, in the description field, you could see that the description is brown, leather, female, and separated by commas. Now, probably if we look at this, I mean, in terms of the description of this, it says there is color in it, the material, and the gender are three separate items. How could they all be in one field? They cannot be in one field. Okay, why they cannot be in one field? Based on whatever experience you people have had of creating databases, you would realize that, say for instance, if I want to search for a particular data item that has a certain color, how would I perform that search if within that field I do not only have information regarding the color but also the material and the gender? It won't be possible. So non-atomic would mean, as I said, and if you look at this example, you have more than one data items stored for a single field. Actually, it should be a single data item. So ideally, if we want to keep it, or if we want to make it atomic data, the description field should be divided into three separate fields, which would be color, material, and gender. So that if I want to search on any particular characteristic of a product, I can use that, uniquely in a way, uniquely in the sense that, without any repetition of any other data item, so that I can search for it. So if I separate these into three separate fields, such as color, material, and gender, if I put in a condition to search for all the products that are brown in color, I would be shown a list of all the products that are brown in color. I would not have to worry about what else is there because there would not be anything else. Are you getting it? Okay. So this is what is meant by data being non-atomic, and the objective is to make sure that all the fields contain atomic data. Okay. Repeating groups of data is when fields are repeated for each record. Repeating groups of data is when fields are repeated for each record. Well, what does he mean by that? Now, if you look at this table, you could see that there's surname, forename, and then there's subject 1, subject 2, subject 3, subject 4. This is a repeating group of fields. What does it say? It says the subject has been repeated. The subject field has been repeated. This can be a problem when trying to search for all students studying the same subject. If you look at it closely, um, physics, in one case, the physics is subject 4. On another occasion, physics is subject 2. You see that? Now, if I want to look for all the students who are studying the same subjects, how can I perform this search? If I'm not being consistent about how I specify the subjects. Yeah. So I have repeating groups of subjects. Ideally, when you take this database through the stages of normalization, these should be separated into a different table, not all together, and there should not be any repeating groups of fields such as subject 1, subject 2, and so on. Not only this, what if a student doesn't take 4 subjects, a student only takes 1 or 2 subjects, then the rest of the fields would have to be blank. What if there's a student who takes a fifth subject or a sixth subject? How would you accommodate that? Okay, so basically, this is what is meant by repeating groups of fields, and of course, this should not be the case. And then another example where a table contains more than one set of data. So if you look at it, there's surname, there's forename, book, date out, and date due. Now this student, Jones I4, has borrowed 2 books, everything in color and Guardian. Date out was this and date due is this. Yeah. But actually this student has issued 2 different books. It should be mentioned in the database as 2 separate events, not just one. And if we take the example of this, Smallwood Stephen, well, he has what borrowed 3 books. And if you look here, all these 3 books, or actually 2 of them, have different dates that they were borrowed, and they have different dates that they're supposed to be returned. How can you put all this into one record? Now, what if I want to search for all the books that are due on a certain date? Will I be able to do that? I will not be able to, because in the date due field, if I use the date due field for this purpose, where I would like to put in a certain date on which certain books are meant to be returned or they are due back, how can I mention a single date out of these when there are in the same record there are 3 different due dates given? Same is the case with date out. Are you getting it? Okay. So basically, you can say that this is an example of data being non-atomic. Okay. And we could also say that a certain set of data in a group of fields is being repeated. All right. So going back, after having looked at these examples, what are the requirements of a database uh, when it has to be converted into the first normal form? After the 0NF or the unnormalized form, the first stage that you take your data through is to convert it into the first normal form, 1NF. So data in first normal form or 1NF must satisfy the following criteria. So for a database to be in first normal form, these 3 things that have been mentioned in this bulleted list must be obeyed. For example, all fields must contain atomic data. We have already discussed this. There must not be any repeating groups of data in our data. And lastly, there must be a unique key or there must be a primary key in your record structure. These are the 3 basic requirements for a database to be considered to have been uh, normalized to the first normal form. All right. So when you look at any data and you have been asked, it is in 0NF or it is in unnormalized form, and you have been asked to convert it into the first normal form, these are the key factors that you would be considering or that you would be analyzing the data against to make sure that all the data is atomic, there are no repeating groups of data, as well as every every record structure, or in your record structure there is a field that you can call the primary key that would hold unique data. Okay, taking it on from here. Okay, now if you look at this example, there's an order table below that contains details of products ordered by customers. There's an order table that contains details about the products that have been ordered by customers. If you look at the list of the fields, there's order date, customer ID, customer name, customer address, then there is product code, description, price, description, quantity, and price. If you look at these fields, how many different, I would say, entities can I take out of this? Or how many, yeah, or how many different, maybe, how can I differentiate in terms of the purpose? How can I differentiate these fields from one another? How many groups can I divide this into? You said three. Do you all agree with that? It is actually three. You're right. It is actually three. How? There's information regarding the order, there's information regarding the customer, and then there's information regarding the product. Should all this be combined into a single file? No. That is what the objective is. How can all this be together in a single file? So, order data has to be separate, customer information has to be separate, and the product's information must be kept separate. And then, in some way, using, of course, the database normalization, you must be able to relate them in a certain relationship so that they're all connected. All right. Now, looking at this, if this data, if we consider that all this is in unnormalized form, UNF, if this was to be converted into the first normal form, what is it that we'll have to do to this data? All right. So, by the way, this is the example that we are going to now use to carry it through from 0 NF to the third NF, because there are three normal forms. Starting from 0 NF or unnormalized form to the first normal form, then the second normal form, and finally the third normal form. So it is going to be the same example, so that for the sake of consistency and continuity, we can see how a particular database which starts with a single flat file gets converted into a set of related tables. So we have the UNF, the unnormalized form. If this was to be converted into the first normal form, what will we have to do to this? Can anybody repeat the stages or the steps in the first normal form? I just told you the three things. Okay, the data should be all atomic. There should be a unique or a primary key. There should not be any repeating groups of data. Very good, exactly. Okay, so this is what we need to sort of analyze this information against. Now, a unique field or a unique key could be the order number, and you could see that he has underlined it. Atomic data, customer name and customer address needs breaking down. Have you ever noticed, even with whatever examples that we have done so far of database, doing it practically, you would have noticed that customer name is usually not a single field. It is usually always split into first name, last name, or forename, surname. Okay, so that uh, the data can be made atomic. If the first and the last name are stored in the same field, then I cannot perform a search on any one of them. Say for instance, yeah. So usually you split names into separate fields. Same goes with the address field. You do not put in the entire lengthy address into a single field. Usually you would have seen it is a case of address 1, address 2, or maybe address, and then it is about maybe city, postal code, country, or something like that. Okay? Or it could even be address, locality, or something, and then further up in that, maybe it could be a case of city and country. So basically, you split the address field into parts. So it says that the customer name and the customer address needs breaking down. No repeating groups of data. Products are being, or the products that are being ordered are being repeated, or they would be repeated. Because if you look at this, if you look at this, it says you could see that a particular product may have to be repeated for one customer or more than one customers. That would create repeating groups of products. Okay. So what does the order table become? After having done these changes, what would it become? Let's see. Order table, the name of the table in block letters. Order number, which is the primary key being underlined. Order date, customer ID, and now see customer forename, customer surname. The name field has been split into two parts, forename and surname. And then customer address 1, address 2, address 3, zip code. The address field has also been split into four parts, making it atomic. Okay, a new table for the order of products will have to be made at this point because products would form repeating groups of data, as we could see through the example. So, creates a new table called order line in which order number would be the primary key, and then there is product code, description, quantity, and price. Now, you would have noticed one thing here that he has underlined not only the product number but also the product code. We will look at this in a bit as to why is this the case. But he is giving some explanation regarding why order number has been included again in the order line table. You get any idea of why has this been done? Yes. In order to establish a link or a relationship between the order and the order line table, you will have to repeat the order number. Yeah. So if you look at the description, it says order number is retained in the order line table as a foreign key for a one-to-many relationship to be established. Yeah. However, it is not unique, so cannot be used as a primary key. Do you think that the order line table must have a primary key of its own as well? We do know that on the foreign key side of the relationship in uh, the other table usually has its own primary key. Order number is the foreign key, but the order line table should have its own primary key. All right. So just keep that in your mind. For the time being, we have split this information that we started off with, as a single flat file into two tables for the time being, the order table and the order line table, so that they can be linked. And we have put all the information that would forming repeating groups of data, which was the product info, into a separate table called the order line table. Yeah, and all the rest of the information goes in the order table, where in the order table we do not only have the order data, but we also have the customer data. But we have made it a point that we make it all atomic, as well as we do mention a field which is to be set as the primary key. So have all the basic rules of database being in the first normal form satisfied? Are they satisfied now at this point in time? For this example, yes. Let's move on. Okay. Look at a term that has been mentioned here, which is a compound key. It says there is no primary key for the order line table. However, of course, the order number that has been repeated in the order line table is not unique. We know that. So, a combination of order number and product code are unique, so they become a compound key. Did you get this? Sometimes we can make a primary key by using a combination of keys. True, keys means fields. Okay, two, even maybe three. So if you combine some fields together, okay, you can call them a compound key because combining them together will give uniqueness to your records. So if you look at this, order number and product code combined together can represent one record uniquely. Order number alone cannot represent a record uniquely because order number in the order line table is a foreign key, so it would have been repeated. Yeah. So how can we make it unique? We can make it unique by setting up a compound key on order number and product code. Now these two combined would make every single record unique in this database table. All right. Okay. This will become more clear as we go on, but for the time being, you know what a compound key is now. All right. You can call it a composite key as well. Composite key, compound key, both terms can be used. Okay, after having converted our information from 0NF or unnormalized form to the first normal form, we now move on to the second normal form. Let's see what is the second normal form and what are its requirements. Now, the first and the most basic requirement for a database to be normalized to the second normal form is that your database has already been normalized to the first normal form. That's the first requirement. You cannot convert a database into second normal form without having been, changed into the first normal form first. So you change it into first normal form and then you move on to the second normal form. Okay, data in second normal form or 2NF must have no partial key dependencies. This means that no non-key data, no non-key fields can be dependent upon part of a primary key. This therefore only applies to tables with compound keys because there are or they are the only tables that can have partial keys. Does this make sense to anybody? Read it. Come on. Okay, a couple of terms that have been used here. Uh, we know what a primary key is. We know what is a compound key. What are non-key fields? Non-key fields are all the other fields that are not a primary key or a compound key. All the rest of the fields are called non-key fields. Yeah? No, 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 it's not that. It's not that. Okay, so what does this mean? What does this mean? It says for a database to be normalized to the second normal form, it is important that in case you have a compound key, you need to make sure that no non-key field should be dependent upon only part of the primary key. because the primary key has been made by making use of two fields together to make them a compound key, so that together, those two fields together is the primary key. No non-key field should be dependent upon part of the primary key. Okay, or there should not be any partial key dependency, which means what? No non-key field should be dependent upon only one of the fields in the compound key, such as there should not be any field that is only dependent upon either the order number or only dependent upon the product code. All the non-key fields should be fully functionally dependent upon the compound key or both the keys together. Now, what is meant by this? I mean, if you look it through the example, let's see. So we had two tables, the order table, and we know what the fields that there are in the order table, and then we had an order line table in which we have order number and product code, and these two combined together makes a compound key. All right? Okay. Only in the order line table contains partial keys. Description and price are dependent on product code, which is part of the compound primary key. Now think logically. Do you think the description and price fields are dependent upon order number? No. They are directly related to the product code. Because product can have a description, product has a price, but order doesn't have a description or a price. So now you get it. What is partial key dependency? Partial key dependency would mean that, well, in this case, description and price are only dependent upon the product code, they are not dependent upon order number. So there is a partial key dependency. This cannot be let to happen when you are normalizing a database or when you are creating a database and normalizing it. So whenever this is the case, what is it that you need to do? You need to take out the field that is the partial key that has dependency of certain fields and the fields that are dependent upon it, and make it a separate table. So if you look at it, you make a new table out of this called the product table. So you make the product code the primary key in that table, and the description fields and the price fields go with it. A new table is made because this was the part of the compound key that these two non-key fields were dependent upon. So what do? You take this field out of this, make a new table, set this up as the primary key, okay? And the fields that were fully functionally dependent on only this, which is part of the compound key, you make a separate table out of it. So something that started off with UNF or 0NF has been now converted to the second normal form. By the way, when it comes to second normal form, you would only actually worry about second normal form if there is a case of a compound key. But if there is no compound key, then there is no second normal form. You will have to convert your database into second normal form only and only if there is a compound key and there is a case of partial key dependency. Did you get it? Yeah? Okay, very good. Now again it says the information stored in the order line table that is not part of the product table needs to be retained. So the order line table still contains order number, product code and quantity for the sake of uniqueness. Okay. The product code field is retained in the order line table. The product code field is retained in the order line table, as a foreign key because it is still necessary to know which products were ordered. All right? For the sake of creating relationships. Otherwise, we would not be able to link the tables together. Yeah? Okay, moving on. Lastly, the third normal form. And this is where we will stop. Okay. In our course, we only have to learn to normalize the database up to the third normal form, although there is a fourth normal form and a fifth normal form as well. Okay. But that is beyond the scope of this course. So we only have to learn it till, normalizing a database to the third normal form. Now, as the rule says, as the rule applies, for a database to be converted to the third normal form, it first has to exist in the first and the second normal form. Only then can you convert it into the third normal form. So, what is it that is required at the third normal form? So, data in third normal form or 3NF must have no non-key dependencies. Now, this is something new again. This means that there should be no fields that are dependent upon an other field that is not a primary key. For a database to be converted into the third normal form, you need to make sure that in none of the tables is there or are there any non-key fields that are functionally dependent upon another non-key field. So we can put primary keys and compound keys on one side. They are not concerned at this stage. We are only talking about all the non-key fields here. We are not concerned about the primary keys or the compound keys, for a database to be converted into the third normal form. Why? Because here, what is it that we are checking basically? We are seeing that in all the non-key fields, are there any non-key fields that have their existence dependent upon some other non-key field? If that is the case, then the non-key fields that are dependent on another non-key field, that non-key field and the ones that are dependent on it must be taken out and made into a separate table. You create a separate table out of it. Are you getting this or not? Did you listen to that? Okay, yeah. So let's have a look at the example. So, all right. How many tables have we had so far? We have had three tables. The order table, yeah, the order line table, and the order table. Sorry, yeah, the order table, the order line table, and there was a product table. Now, if you look at the order table, order number is the primary key. There's order date, customer ID, customer forename, customer surname, all the address fields and the zip code. Yeah. By the way, this is the product table, so I'll label this 2, and this could be labeled as 3. Okay, have a look at this information. This information. It says in the order table, all customer data is dependent upon the customer ID, which is a non-key field. A new table needs to be created called the customer table. Now have a look at this, the order table. Don't you think that the customer forename, surname, and the customer address, or the existence of these fields is totally dependent upon customer ID? And customer ID here is a non-key field. So what is the rule with the third normal form? That if there are any non-key fields that are functionally dependent upon another non-key field, then you take them out and you make a separate table out of it. So what do? You take the customer ID out and all the fields that are related, and you make a new table called the customer table, which will be the fourth table. So customer table would have customer ID, and by the way, this should have been underlined, okay? Forename, surname, address 1, address 2, address 3, and the zip code, okay? So the order table now becomes, after taking the customer information out of the order table, the order table now becomes order number, order date, customer ID, yeah? And this would be linked to the customer table on the basis of the customer ID. So customer ID here would be the primary key, actually. Here in the order table, it will be the foreign key, because here it would have repetitions. Because what if the same, different orders have been placed by the same customer, one to many. So in the customer table, customer ID would become the primary key automatically, all the rest of the fields of course being dependent upon it, and you will have to keep it still there in the order table so that you could join the customer and the orders tables in a one-to-many relationship, keeping in mind that uh, one customer may have placed many orders. So these are all the stages that you make the data go through to normalize it to the third normal form, okay? And you would have seen that through this example, that something that started off as a single flat file, and we at the very start we figured out that there are three different distinct pieces of information in terms of their nature and in terms of how they logically relate. And when we make this data go through the stages of normalization, first normal form, then the second and the third normal form, at the end of it, we achieve four different tables that are related to each other in a certain combination. So this is how a single flat file may result into a set of related tables when you make it go through the stages of database normalization. And this is a standard practice. The rules are there, the rules are a standard, and whenever you're doing database normalization, these are the rules that you will be following always or every time. And when of course, you follow the rules, you would notice that it is always the case that towards the end, you get a set of related tables with the proper relationships and of course the primary and the foreign keys specified. All right? Is this clear? Any question, anyone? Okay, very good.